Welcome to this session. This is Performance Tuning, Big Bang for Your Buck. This is the session I love to give to all levels of SQL Server, because this one works as a checklist for items that you should be looking at inside your environment to get the biggest performance tuning gains that you can get possibly with the littlest amount of effort in doing so. I find even if you are a senior DBA that some of these things in your environment go by the wayside, and you kind of forget what exactly you should be doing in an environment that you've had for a long time. It's good to go back and check things. So let's get started. I'm Monica Rathbun. I am a consultant with Denny Cherry and Associates. I am very, very active in the community and a Microsoft MVP. There are lots of scripts and things that I will be talking about throughout this presentation for reference, and you can find all of those at SQLespresso.com. I'll put it in the chat when this is actually finished, so you guys can look for those scripts and the different blogs that I will mention at that website. Also, you can reach me on Twitter. That's probably the best place to ask me any questions or to follow up with me. It's SQL Espresso on Twitter as well. So let's go ahead and get started. I do know that this is only an hour presentation, and I tend to do this one at 75 minutes to 90 minutes. So I'll apologize if I rush through a few things, but you can find the slide deck and everything you need to follow up and to ask me any questions after, again, at SQLespresso.com. So let's go ahead and get started. Here is my presentation rules. I find it really useful as I'm going through this, what I call checklist of items. If you happen to find something that I talk about that didn't quite work in your environment, or that you may have had an adverse effect on it, go ahead and let us know. You can interrupt and ask questions at any point in time. Hopefully, if time allows, I can get to all of those questions and comments. There is always things in every environment that differs when you go from one environment to another. And some of the things I may tell you to turn on or do may not always work in your environment, or you may have had an issue for that. Always remember, anything that I tell you, you should be doing in test first and checking it in your development process before actually doing it in production. Let's go ahead and get started. I always start with best practices. These are the things that when you have an environment that you should make sure are aligned and correct throughout every environment that you have. And some of them are really simple. Some of them are outside of the SQL Server realm, but still make a huge difference in performance in your environment. So let's start there. I like to give you this screen as a checklist that you can print off, grab from my website as the items that I really want you to check right away, and go back and check, as early as tomorrow or later today. And let's start with the first thing, which is actually outside of SQL Server. Many of the things that I'm going to talk about is outside of the DBA's hands that you may not realize is actually causing you performance in your environment. This is the number one thing that I find, and you would be surprised how much it makes an impact. And all it is inside your Windows box, whether it's a VM or whatever you have, bare metal or wherever you have your SQL Server on, it is actually a power option inside that. Now, whether that's actually on your VM itself or actually on the host, this should be set to high performance power plan. And the reason why is, without that, pay attention to this number. If you are on the balanced power plan, which is the default setting for most installs when it comes to Windows, and on the host, you are only using 70%. Look at that number, everybody. 70% of your CPU. That means you already have a 30% reduction in CPU power for your SQL Server. Okay? So what I need you to do is go back to your environment, double check this. There are some BIOS settings that can actually go along with this. It makes differences, especially if your high performance is grayed out like this. So do your research at this level within the 60 minutes. I'm not going into everything having to do with this. However, what you need to go back is make sure that's chosen on high performance power plan, and you will immediately gain back 30% more power on your CPU. Again, this is on your actual box as well as any host that you may have inside a virtual environment. There are ways to actually test this improvement, and there is something called CPU-Z, like zoo, CPU-Z, and you can actually run it before and after making this change and see the clock speed difference and the performance gain that you're going to get with that 30% increase. So you can actually show that to your admin if you do not have rights on the box to make this change. Next thing we're going to look at is services. I can't tell you how many times as a DBA consultant that I've run into an environment where everybody has gone through the SQL Server setup and hit next, 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 and installed everything having to do with SQL Server on a box because either they didn't know what it was or they weren't sure if they were going to use it, or maybe you had plans to have SSIS on the box and then later no longer use that service. I want to make sure you're turning off anything that doesn't have to do with the engine if you're not using it. Not only turning it off, but setting that to disabled so when you reboot the machine, it doesn't reactivate it and turn it back on. All of these different SQL Server services that are out there takes away from your engine. We want to make sure as much resource is going to that engine, running your SQL Server to the best capable. And a lot of these actually we will go through uses memory different and uses other resources within inside the Windows box different. And we need to make sure if we're using these services, we have those properly configured as well besides our engine. Your best bet is to not run any other services but the engine on a box. And I do know that many people run into licensing issues. And the reason why we have things such as SSIS running on the same box is to save us money. I certainly understand that, but make sure when you have services like this running, you know the impact on the engine before doing so and turn off, again, anything that you're not using. Go back and check this. You'll be surprised what you're actually running on the box if you've not actually looked at this recently. So the next thing we want to talk about is patching. Again, this is outside of SQL Server for some of this, right? Many people look at patching when it comes to security, right? You always make sure you're on the latest and greatest Windows patch. You make sure that you are keeping things updated for security purposes. But what people don't think about, and it's outside of the box, is really patching has a ton to do with performance gains and performance degradation. In every single CU or service pack, there are actually performance improvements and bug fixes that are part of it. I doubt many of you actually go through all the KB articles when it has to do with each bug fix that is being put into a CU or each additional change that's happening within every single CU or SP that's released. But there is a ton of things, including metadata fixes that happen in the background and different things that change within the engine that makes our SQL Server faster and solves problems that we may not already know about. Again, SQL Server makes every improvement with every single deployment that it has. So 2016 SP1, there was actually huge changes to the optimizer that increased performance. So if you were on SQL Server 2016 and you have not gotten to SP1, which I'm sure many of you have already done this, you are missing out on a huge change in the optimizer that made our stuff go much faster. The last thing is, are we looking at, are we on the latest versions, supported versions for Microsoft, right? If we have a problem with performance or within our environment, if you are not on the most recent supported version, you are also having to call Microsoft and say, hey, I have a problem. And they say you're not on the supported version, therefore we cannot help you, and hang up the phone. And then you got to call consultants like us to make those changes. So make sure you're on the latest for that reason. Lastly, again, outside of the SQL Server realm, your drivers on your VM, your NIC cards, your controllers, Windows patches, all of this plays a huge difference, huge impact on performance inside SQL Server. Have conversations with your administrators and make sure that that is actually being patched, which can actually give you performance increases inside your environment just from having those conversations and making sure they're on the latest and greatest. All of this has to do with performance inside SQL Server when it comes to patching. So here's the next one. Let's talk about memory. Everybody knows memory is critical to SQL Server. We want to make sure all of our data stays in memory as long as possible so we can get reuse and stay away from bottlenecks like our disk, which can introduce other issues. If you go into your SQL Server and you go to properties, again, for some people this may be elementary. For others, they'll look at your environment and you'll see this max memory with this huge number, 214748367. That means your memory is being neglected inside SQL Server as a DBA. You have not gone and tuned this number. What this really does is if you have this number here, you're telling the engine it can take all available memory on your box and use it. doesn't sound bad, but that means you can actually starve your OS and you can starve other services that are on your box. What you need to actually be doing is to know what number goes in there. Now, some people say you leave 10% to the OS and everything else goes to SQL Server. Others, like myself, use scripts that are out there. If you look for Jonathan Cahias for SQL Skills, I'm going to leave that link for you later. He actually has a script you can run to determine your max memory, and he will give you the magic number. It's based on a bunch of math that you put in this box right here for the setting. And what that does is it tells SQL Server, let's say I have 64 gigs on the box. Jonathan tells me that I need to have 56 gigs for SQL Server, and the rest is going to be left to the Windows OS, right? So I'm going to put 56 gigs in this, and that tells SQL Server it can use memory up to 56 gigs, and everything else is left to the OS or the other services to use. You want to make sure you're actually filling in this number so you can control the memory that's allocated to SQL Server. Now, many of us have multiple instances on our boxes. If you find that you have multiple instances installed, you want to make sure that max memory is allocated correctly between the multiple instances. Let's take that box that has 64 gigs that I just talked about. If I have multiple instances, I cannot go and put 56 gigs in each instance as my max memory, because what did I just do? I completely over allocated the memory on that box. Okay, so if you find that you have multiple instances on your box, I need you to go to them, check the max memory, and add up those numbers and make sure you are not over allocated your memory. Not only by doing this are you starving your other engines that are installed, but you're also starving your OS, which can cause major issues. So double check that. I've seen it several times where people have over allocated this. So let's not make that in our environment. Secondly, these extra services that I talked about, SSRS, SSAS, SSIS, all of those, did you know that it does not use this max memory setting? If I have this set at 56 gigs, then I've only left, 8 gigs to the OS. That 8 gigs that I left to the OS is also shared by SSIS, SSRS, and SSAS. Okay, any other extra services that you've installed. So if you've actually allocated everything to the engine or did not leave extra for these things, you can find that your SSIS creates a low Windows memory alert for you every morning as it moves all your data into your data warehouse. Or your SSIS is running really slow, maybe because it doesn't have enough memory allocated because you only left a little bit to your OS in which it's shared. So I want you to do your research. I want you to look and see what your other services are actually consuming in memory. And you may have to adjust this max memory setting inside your engine to free up some more stuff for the OS and the other services to do this, okay? The next thing you're going to see is lock pages in memory. I've got a star for this. I don't have time to actually go into this. It used to be a best practice setting where you had to turn that on for each one of your environments, but I want you to do research on that. There is some give and take on whether that should be installed in your environment, so I'd note it here as one of the things you should look at. Lastly, if you are on a VM, this is really important. So say you're using VMware and you're on a host. There is a thing called a memory reservation. I want to go to my admin and say, I need 64 gigs as a memory reservation for my VM. What that means is once that memory is reserved for this particular VM, that host can no longer touch that memory. There is a thing called a balloon driver, and what the balloon driver does on a VM host is it says, hey, I've got one VM that needs just a little bit more in order to run this process, so I'm going to steal some memory from this other VM that's not quite using it yet to do what I need to do, and then maybe I'll give it back. Well, when it comes to SQL Server, I never want anybody to touch my memory. I don't want that balloon driver to actually steal memory from me to give it to another VM. So I need to ask my admin to make sure I have a memory reservation for the amount I've asked for. When they click the little box, it's just a checkbox that says that you want a memory reserve amount for this VM, then nothing can steal the memory from you. Okay, so I need you to go back and make sure you actually have that setting correctly on the VM. And usually that's outside of the DBA's realm and you have to ask somebody else to do that. But just double check and make sure you have a memory reservation set for the amount that you asked for. Okay? So next is TempDB. I have a full session on TempDB. We could talk about this for hours and hours and hours. But here is what you need to know as a bare minimum when it comes to SQL Server and the way your TempDB is set up. It's so important to have it this way that many of these items are actually taken care of in SQL Server 2016 and forward as part of your setup process, because they want to make sure you have it properly configured in order to have SQL Server run the best as possible. Now, what we want to talk about is making sure it's on the fastest as possible, right? Making sure all of your temp data files and log files is on SSD or some kind of flash or something that's going to make it fast, because everything inside your environment uses TempDB. The engine uses TempDB. There's metadata that goes on in TempDB. There is all of our regular temp tables. We've got our sorts. We've got all kinds of things. They're all vying for the same resource for the one TempDB that we have. So we want to make sure we're able to combat things like contention, which is the #1 problem with TempDB. Everybody vying for the same open space in order to do the workload. So how do we mitigate contention? It's all about our configuration, okay? First of all, we want to make sure we have multiple files for TempDB. And you can actually, for the data side, you can actually use the rule of thumb of 1 file per CPU core. On this box, I actually have 4 cores, so I have 4 files, up to 8 files. Now, why do we say up to 8 files? There is a give and take, a rate of return that the threshold kind of falls off after 8 files. However, 8 is not a stop date, not a stop number. If you've got a really large environment, you may actually benefit from more files. However, most of us are going to do well with 8 files. And what that does is allows it to actually allocate workload throughout each one of these files. So you get a round robin effect of how it does its algorithm to what pages it can write to. You get multiple PFS pages and GAM pages, and we're not going to go into all of that, but there's multiples based on the amount of files that you have, which allows the workloads to be properly allocated in your environment. So you want to actually make sure you have multiple files on that. On top of that, you need to make sure that they are all sized exactly the same. And this is where many people run into problems in their environment. I guarantee you, some of you in the audience right now is going to go to your TempDB, you're going to right click and go to properties, and you're going to see one file that's out of line space-wise compared to others. What happens when that occurs is that, again, we're talking about a space allocation for your workload to happen. If my temp dev file here was 10 gigs and everything else was set at 1 gig, then all the workload coming through is going to try to do its workload in my temp dev because it seems to have more space, right? You want to make sure you're keeping everything spaced exactly the same. The size should be equal throughout all files so the workload can come through equally and allocate properly. If you get one file that's out of whack, that's bigger than the rest, then all of your workload is going to that one place and you have a contention issue. You have problems in your environment, I guarantee you. So make sure they're all sized the same initially. Make sure that if one grows, they all grow. And how do we do that? Prior to 2016, we had to manage it with trace file 1118 and 1117. 1118 had to do with mixed extents and things in the background that helped with the allocation. 1117 has to do with auto growth. Making sure that your auto growth is exactly the same on all of your files. 1117 will say if my file number 1 grows, all of my files are going to grow in sync. And that's how they stay aligned size-wise. So you want to make sure you turn that on so you can keep that intact and everything stays the same. Now, after 2016, that's a defaulted behavior, and SQL Server takes care of that for you, so you don't need to worry about it. Your main objectives here is to make sure they're all sized exactly the same, the auto growth is exactly the same, and if you're prior to 2016, you have those trace flags on. Now, we talked about contention being the most important thing inside TempDB, right? Everybody's vying for the same space. Did you know if you are not on SQL Server 2016 CU8 or 2017 CU5, you actually have contention issues on the metadata layer inside the engine that were actually fixed. It makes TempDB go faster in these CUs or higher. So like I said, when it comes to making sure you are on the proper patching regimen, things like this get fixed in the background, and you probably didn't have any knowledge that this actually existed. So make sure you take care of that. Now let's talk about temp tables versus table variables. If you use table variables and you are not on SQL Server 2019, then when you look at your execution plan, and I don't have a visual of this, but hopefully you guys all know, when you use table variables, it shows an estimated row count of 1, and your actual row count may be 100,000, okay? But what happens is all of your execution plan is going to be written, and all of your operators are going to be written based on one row coming through, which means your memory grants aren't correct, your joins aren't correct. There's different things based on the estimated versus actual counts that make a difference and force you to spill to TempDB. Well, what happens when you spill to TempDB? You go to disk, right? TempDB is on disk, and you're not in memory, which can cause a bottleneck in your performance.
You can turn this on without zero impact in your environment. 2453, it's very important. It is so important that it is defaulted in later versions and corrected in 2019 with table variable deferred compilation. Now what this does is it allows it to trigger a recompile before things are run, and it'll actually give you the actual rows instead of the estimated number of 1. So you'll be working on the 100,000 rows, which will give you the proper memory grant and the proper joins and help the optimizer give you a better plan. So 2453 gets rid of that estimated count of 1 and will make a huge impact if you place that in your environment. Now, like I said, I've got a whole session. We can talk about that for hours, but since we don't have all of that time, we're going to move on to the next setting you should be looking at, and that is max degree of parallelism, which is your max stop number, and that works hand in hand with your cost for threshold of parallelism. Again, this is so important that starting in 2019, it prompts for this in your install. So this is a number that you should be taking a look at, and I'm going to explain it a little bit here in detail. But if you look in your environment and you go to properties and you see that your max DOP is set to 0 and your cost for threshold is set to 5, that means these two options have been neglected in your best practices, and you really need to take a look and get these settings correct. Now, max degree of parallelism says that when an operator decides that it can benefit from going parallel, meaning multi-threads, to do the operator, then it will look at your max degree of parallelism. If you say that I have 8 cores, I'm going to allow 4 threads, 4 cores to work on something, that would be your max DOP number. If I had 8 CPUs, my max DOP would be 4. I like to start off with half. Now, that's just the best practice on mine. You can actually do up to 8, but I like to do it at 4, which lets me start out with half of the processors or half of the threads to be able to be allocated to this particular operation. When you go a max DOP of 8 or more, again, we get the cost benefit analysis. Too many parallel threads can cost you when it comes to parallelism and these what we call CXP packet weights, which I'll explain in just a second. So what you want to do is I like to start out with half of my logical cores as my max DOP setting, and that's what I'm going to set there. Then I'm going to look and see if that works. If I end up with a ton of weights, I will adjust that accordingly. But again, I like to do half. Now, caution, this is not a setting that you want to do in the middle of the day because it will flush your procedure cache. So make sure you're doing this on off hours. If you do it during the day when it flushes your procedure cache, you will get a performance hit as that cache rewarms back up, and then you can get the plan reuse. If you have one plan that actually benefits from going serial, meaning that you want it to use 1 thread, you can actually do the max DOP setting as a query hint inside your statement. So you can play around with that as a performance tuning tool as well. Now, how does this work with cost for threshold? Cost for threshold says for that operator inside the execution plan, it must be a cost of, I like to change this number to 35 or 50 as a good starting number. Maybe the cost has to be 50 before it decides it can go parallel, which means it's going to use multi-threads.
That's what I like to look at. That's what I like to set. You'll notice in your environment, if you have a ton of CX packet weights, that could mean you have a ton of threads trying to be put back together to move to the next operator. And maybe you should be adjusting this parallelism cost number so you end up with less CX packet weights. Now, CX packet weights is something that goes through every environment, which is a normal weight that you will see. When threads actually spawn out to multiple threads, the max DOP, let's say that's 4 in this case, when those 4 threads actually branch out to do the work, once the work is done, those branches have to come back together into a singular thread, a singular data combination here, and move it on to the next operator. That is called the CX packet waits. It's bringing those threads back together to perform the next action and decide whether the next action has to go parallel or not based on this cost. So too many CX packet waits could mean you have way too much overhead of bringing all of those threads back together to move on throughout your execution plan. So that's when you start to adjust this cost per threshold for parallelism item. But a good place to start, if this is set to 5 in your environment, go ahead and change it to 35 to 50. That's pretty much a safe number, and kind of keep an eye out on how your parallelism is working inside your environment. So those two numbers work together. Next, this one is simple, and this one is outside of SQL Server. And it's so important, again, that when you go to 2019, there is actually a little checkbox in the install that says to grant this permission and enable IFI. So this is inside your local security policy on your host. On your VM, I'm sorry. So whatever VM you have or whatever environment that you have, on the disk side, this is a local security policy under user rights. And all you want to do is put your SQL Server service account, the service account that is actually running as your SQL Server, you want it to have perform volume maintenance task. If you're using a group policy, you want to make sure this is set in group policy so you can have this on all of your boxes. And what this does is when you're on the file system, it actually has to zero out the space it needs for whatever operation it's doing before it can write to disk. So if you have restores, if you're adding log files, if you have an auto growth scenario, or you're creating a database, and I'm going to show you here in a second the benefit of this, it avoids zeroing out those operations. So when it goes to disk, it immediately can write to that space that you need for whatever it is, if it's creating a database or whatever, without having to do that pre-operation. So it makes things go much faster. And I can illustrate this really easily. Let's say we have a 5 gigabyte database that has IFI not turned on, meaning it does not have the service account with the permissions it needs to avoid that. Look at this. I created just a simple 5 gig database. It took 1,800 milliseconds without IFI turned on. That means it had to zero it out. It had to prep the disk for it to actually be able to use it. With IFI turned on, it took a third of the time. So if you can imagine creating a large database or doing a restore where you have to write to the disk and it's a really large file, we're talking hundreds of gigabytes, terabytes, petabytes, whatever it is, and you don't have IFI turned on, the amount of time wasted while it waits to create that space and initialize it for you is really significant. So again, if we look back, these are the operations, restores, adding the data files. Your auto growth is a big one. If you've got an auto growth scenario, you want it to go as fast as possible so you don't get that performance hit as it waits to grow. The IFI makes a huge difference for that. There's scripts out there that you can run to check for IFI if you cannot get to that Windows permissions level in your environment because it's blocked for some reason. Just look up Instant File Initialization SQL Server. You can find the scripts to check to see if this is on. Again, when it comes to 2019, it's another very important feature that they put it in the GUI as you do the install, and it's a checkbox for you to grant these permissions. So next, this is a magic button inside SQL Server. This is so important that later they've actually turned this on, and we're going to talk about this a little bit more and why it's so important. But many of us as a DBA deal with blocking, right? Blocking is a huge issue for us, and that's actually created by design. Readers block writers, and writers block readers. Right? That's what we want in the environment. However, there are ways to mitigate what these blocks actually do and all the performance hits that we get from these readers blocking writers and writers blocking readers. And it is called Snapshot Isolation. It's read committed Snapshot Isolation, or most of us know it as RCSI. And before you turn on RCSI in your environment, you've got to make sure you go back to that TempDB setup that I talked about and make sure your TempDB is properly configured and spaced appropriately before you talk about turning on this option. But what happens is it uses TempDB to create a version store. And it starts to track any changes that happens within inside your tables inside TempDB. And when it goes to do a select and an insert and update and delete, it's going to look at that version table in order to actually get your results set. And it's going to prevent blocking because looking at the version table allows the table itself to be updated. And it's tracked through the version, which is what you're going to read. Hopefully that makes sense. But readers will no longer block writers, and writers no longer block readers. Now, people say, am I going to read some dirty data, or there's any issues that you have with that? The answer is, in a very, very rare scenario, there's a thing called race conditions, which only affects a very minimal amount of the environments that are out there. So it's really not a concern. It's so important that it is defaulted in Azure SQLDB, which means thousands and thousands and thousands of clients are running on this. It is the magic button inside SQL Server. I will turn it on in a blink of an eye in every environment that I have, because it gets rid of that blocking and allows things to run much, much, much faster, like significantly faster, and you don't have the issue. Again, it's the default isolation in Azure SQLDB. It is two options. There is the read committed snapshot isolation that you turn on the database level, and the secondary option is the allow snapshot isolation equal to on. Those two work in hand. RCSI prevents the reading and writing blocking that happens, and the allow snapshot actually gives permission to use the row versions as part of your transaction. But again, it uses TempDB. So make sure your TempDB is properly configured. You will have additional storage requirements inside your TempDB because of your row versions that actually happen there. So just keep that in mind, that you will incur that cost. But it is a huge fix when it comes to blocking. I can look at an environment that's being monitored. When they turn this on, I can immediately tell you when it's been turned on. It's that significant and making things much faster. So definitely take a look. Kendra Little has a fantastic blog about RCSI. I recommend you take a look at her blog. Again, that's Kendra Little. And she will do an in-depth explanation about this. But it's definitely an option that you should turn on in your environment. Again, do your research. Make sure you know exactly what it's doing, but it's a huge, huge, huge performance gain in your environment. So let's talk a minute about virtual log files. And I can go into this really for a long time as well, but I'm going to keep this simple. This is all about making performance gains when it comes to startup, inserts, updates, deletes, backups, all of this when it comes to your log file. Now, what happens in your log file, this has to do with your auto growth settings being properly aligned. You actually get what's called virtual log files inside your log file. And every time you have an auto growth scenario, there is math that happens that actually allocates additional virtual log files inside your log. Your job is to keep these VLF, virtual log files, ideally under 300. If you go to my website, I do have a script that you can actually run that will tell you how many virtual log files you have in each one of your logs. I see this as a big issue inside TempDB. I've actually run into environments where the virtual log files is in the hundreds of thousands. And I saw on Twitter the other day that someone had 3 million virtual log files. And that really slows down your environment. Why? If you look at this image that we're looking at here, when a transaction comes through, it has to find a place within the log to actually do the work. Here I have a simple 5 virtual log files here. And it goes through each one of these little buckets to figure out where to write the next transaction. Imagine if you had 300,000 virtual log files. That's a lot of overhead for it to figure out where to do its work. You want to minimize that amount in the round robin scenario of where it tries to find where to do the work. So you want to keep it under 300. How do you keep it under 300? It's all about your auto growth. You need to make sure you're actually setting that auto growth properly. Maybe each one of your log files needs to grow by 1 gig. Maybe your log file needs to grow by 10 gigs, whatever it is to minimize the amount of virtual log files that happen. If you have it set at 10%, or you have it set at 5 or 1 meg or something like that, you probably have a tremendous amount of virtual log files in each one of your logs. And you really need to actually shrink it back down, and you just run a shrink and then properly size and regrow. If I need to regrow my log file automatically out to 20 gigs, and then I have an increment of 1 gig or 10 gigs growth, maybe that's what I need to do in my environment. But it's your job as a DBA to determine and figure out what the best scenario is as far as auto growth to keep these VLFs as small as possible. So when you're having to do these operations, you can do it much faster. There is, going in 2016 SP2, there is a really great DMV that's on log stats. I've got both of them here, so you can see what your VLF counts are in your log files. There's also the DBCC log info that you could use prior to 2016 SP2. So the point of this is go to your environment, run some scripts to figure out how many VLFs you have on all of your log files in your database. If you have a huge amount of VLFs, you have a performance issue. You've slowed down your system, shrink down the files, and then regrow them to a proper size. And then make sure your auto growth is set appropriately so you can be growing in chunks that minimize your VLF counts, okay? Now, this is my favorite slide, and this is the most important thing when it comes to performance in my history that I've run into. All of us really care about our environments, right? We care that when somebody comes and says SQL Server is an issue, some of us take that really personally because we do our best to set our environment as best we can in line with best practices and et cetera to make it perform fast. So I really don't like when somebody comes and criticizes my work or tells me SQL Server is a problem. Well, that plays a big performance thing for us when it comes to our storage admins and our network admins and Azure admins or whoever is in charge with all the configuration to the components that play along with SQL Server. It is our job as DBAs to figure out what is slowing down our environment. Lots of times, maybe that is the storage, or maybe it's a domain controller improperly configured, or it's something. So we have to go to our admins and tell them that their babies are ugly. We have to point out, and usually with numbers, we can prove these things, right? We can easily pull metrics that prove that storage is our bottleneck. Well, nobody wants somebody to point out that their work is not optimal, right? We don't want to point out that our storage is an issue. So how do I get around this and work well with my admins, which is critical to making my environment the best? I keep my admins drunk, fat, and happy. And everybody tends to laugh at that, but it's true. So maybe that means I have to bring in donuts to the admin group or to my storage guys every once in a while. Or maybe I bring a bottle of vodka to the storage or the network admin manager at Christmas time or whatever it is to get on their good side, because a lot of times I need to rely on them. And I ask a lot of them to make my SQL Server go faster. And then I also prove to management that their issue is our problem, right? Their configuration is our problem. So the best thing you can do performance-wise is to make sure you have a good relationship with your network and storage admin or your Azure administrators, right? They get control of some things on how your database is created inside Azure. So I like to make sure I can work with the teams appropriately. I keep them drunk, fat, and happy. We're going to look at a couple of the ugly baby scenarios that really affect SQL Server here. So this is a big one, especially if you haven't made it to the cloud yet and you are still on a VM and a host. Over-provisioned hosts can be a huge issue. I've had this in some big retailers, big name retailers, where they used an off-site hosting company that completely over-allocated every one of their hosts. Too many VMs on one host can cause a problem. And how do you know that from a SQL Server perspective? How do I know where my SQL Server lies, right? What host am I on and everything else that's on that host with it? One, you want to make sure after you bring in donuts that morning that you ask your admin to give you rights to whatever tool is available for you to see inside the VMs. Read only. You can ask, hey, can I have access to vSphere so I can take a look at where my SQL servers are and how they're configured or whatever without changing anything in their environment, but just be able to have view to it. If you notice that too many VMs are on one host, and if you don't have things like the memory reservation set on that host, you can see that possibly that balloon driver could be stealing resources from your SQL servers and allocating them to other VMs on that host. Too many VMs on one host can really wreak havoc when things aren't properly allocated to your SQL Server. Or you're on a box that's really heavily used. You could ask to have your SQL Server moved to another host. that maybe is just for SQL Server boxes. You never know what's on those other hosts, so you have to rely on your admins for that. Because what happens on one VM can affect other VMs. Again, that balloon driver, if I have one VM, let's say they put Exchange, if they're not on Office 365 and they actually have an Exchange server, you don't want Exchange on the same thing as your production SQL Server box, because it's going to steal resources from you all of the time. Make sure you're having those conversations and knowing when they're moving you from one host to another. Maybe that move actually created a performance issue for you, and you're not seeing inside SQL Server anything. It could be the VM that's causing you your issue. Now, one of those indicators, which I saw on this retailer that I just talked about, is they over-allocated CPUs on a host. The host had 16 CPUs, but they ended up allocating 72 CPUs on all of the VMs that are on that host. Yes, you heard me right. The actual host box had 16 CPUs, but when they allocated and gave each VM CPU allocation, it all added up to 72. It was completely over allocated, which meant inside SQL Server, I was seeing SOS scheduler yield waits, which meant my operations were waiting for threads to become available. And my CPU was spiked to 100%. I couldn't get any response from my box because it was sitting there vying for CPUs to be available on that host for my server to actually run. I can see that not only with the SOS scheduler yield, but if you were looking on the the VM host side, there's a thing called CPU ready time. That CPU ready time is an indicator that they could have over allocated those CPUs as well. These are huge things that can cause problems inside SQL Server that are outside of the DBA's DBA to change, but you need to be able to have those conversations with your admins and get these corrected. So that's one of the other ugly baby scenarios that you need to look at. The last thing is thin provisioning. Thin provisioning is a sneaky little thing that your storage admins can do to you. Now, if I ask for a new box and I ask my storage admin, hey, I need 500 gigs for a new TempDB drive. And they say, Monica, you really don't need 500 gigs. It's a brand new box. There's no way you need that much space. And I say, yes, I do. I'm going to have 4 files that are 100 gigs apiece, and then my log file is going to be 100 gigs apiece, 100 gigs. So I do need the 500 gigs. And they say, okay, I will give you a drive, and they present it to me so it looks like I have 500 gigs. But what they really did is that they thin provisioned 50 gigs to me. I saw 500, but in the background, they've only allocated 50 gigs on the disk for me. Every single time I use that 50 gigs, it'll grant me another 50 gigs and it'll grant me another 50 gigs. Well, that is a performance hit for SQL Server, and I never know when that's going to happen. So what you want to do is you want to ask for your drives to be thick provisioned. That means they would give me my 500 gigs right up front. They truly give it to me, and I never have to go through a growth event on disk to get me my full 500 gigs. It's a little tiny checkbox inside their setup. Make sure your drives are thick provisioned and not thin provisioned. If they are thin provisioned and they will not do that, then I want you to grow out your files to the proper size. I'm actually going to grow out each one of my files to 100 gigs so I take up all the 500 gigs of space, and that way I don't end up in the scenario where I have a growth event in the background. So definitely take a look and ask that question to your admins. Find out if it's thick provisioned. Now, the next thing is compression. Here's another sneaky thing that your admins can do. I'm going to get into it in just a second, but I want to talk about the importance of compression when it comes to like indexes, things like that. It is a great thing. Compression allows you to get page compression and row compression, allows you to get more data in memory, which it takes a page and it will actually compress it, but it allows you to move more data to that page. Now, every page has a certain amount of data that's available to be placed on it. We all know this, but if you compress it, then you can get more data onto that page, which means more data in memory, which means I don't have to go to disk. I can get things much faster. So compression on things like indexes is fantastic. It will also save your storage admin on disk space, right? Compression is a great thing when it comes to disk space, when it comes to backups. Your backup compression really can save a lot of data storage and is a good thing. Now, there is cost when it comes to compression. You do cost CPU speed in order to actually get the data compressed and decompressed in order to use it, but it's well worth it. Now, here is the tricky spot. And this happens, and you probably don't even know it's happening, but it makes a huge difference when it comes to your backups. If you have a storage admin that actually said you cannot compress your SQL Server data, if you have a storage admin that tells you to turn off compression, that is a huge red flag for you, and it's very important you have a conversation following that. What that means is that they are probably compressing and deduping, doing deduplication on the SAN level, which is how they're saving space and is really a great tool for them to compress. It actually goes and creates these pointers, and it's the deduplication that gets rid of duplicate data, and these pointers direct them to what that data is supposed to be, which gains them a lot of speed and space savings. But that causes a real issue for you as a DBA when it comes to backup restores, okay? Paying attention for restores. When you do a backup on a deduplicated data, that data gets deduplicated as well, and your backup becomes a bunch of pointers. So what happens when you have to rehydrate all of those pointers? All of that has to be piecemealed back together before the restore starts. So you can imagine we have found that it's 6 times longer to restore a deduplicated backup than it is a native regular backup, okay? I want you to go and test your backups. If you have a storage admin that says you cannot do compression, you need to make sure that you are actually off-siting your backups, whether you send native backups to the cloud, whether you have a different storage array that houses your backups. So when you restore, you don't have to go through that deduplication regeneration that actually happens. You can easily test that. If you test it and it takes 16 hours for a deduplicated restore to happen versus 3 hours for a native restore to happen, you need to make sure your management is aware of those restore times and somebody puts in writing that it's okay for you to have a downtime scenario that's going to last 16 hours versus lasting 3 hours. Okay, it's very critical. It's very, very easy for you to test. Restore a regular backup versus a deduplicated compressed backup in your environment and show your management those times. It is very, very critical. And again, this is a conversation that you need to be having with your admins to find out if they are deduplicating the SAN. Okay, that's the key word, deduplicating the SAN. Now, let's go into this final part, and this is all about query tuning. This is all about making sure our queries go as fast as possible. And that really starts with the estimated versus actual numbers inside the optimizer and inside these statistics that tell the optimizer which operators are best for each operation inside your query. It's important for you to keep these up to date. Now, many people do index maintenance and thinks that updates our statistics. It does when it comes to indexes, but there's also table statistics that need to be maintained. I like to actually set up a job inside my environment that will run and update my statistics on a regular basis. For some clients, depending on the amount of data that has changed, maybe it is nightly that these statistics need to be done. Maybe I need to be doing a statistics update with a full scan on the weekends. Or maybe once a month, I've got to do a full scan rather than the percentage scan that actually happens. Making sure your statistics are aligned is the most important thing you can do inside SQL Server to help the optimizer make better choices when it comes to your queries coming through the system. Keep them up to date. You can easily query your statistics to figure out when was the last time they were updated. That's a good indicator to let you know if your statistics are being maintained appropriately. Now, also in your settings, statistics if you have the auto statistics set on, which you should, it's actually defaulted to synchronous. And what that does is, if you have a percentage of change of rows in your table that triggers an auto statistic update, that can happen anytime. And when that actually happens, it will pause your system, update the statistic, and then allow your query to go through. It could cause some blocking. That hesitation can actually cause you to get a performance hit. What I want you to do is go in your environment and change this to asynchronous. Now, changing it to asynchronous prevents the pause, which makes your environment go faster. It still allows the statistic to be updated. It just goes and it waits for the statistic to update until your queries are finished. Then it will find an optimal time to update the statistic where you don't get an impact. So definitely change this from synchronous to asynchronous. Again, defaulted is set on synchronous. And this is a quick, easy performance tuning thing that will make things go faster for you. This next one It's so important that it defaulted the behavior in 2016. If you're not on 2016, this is something you definitely need to put in. Every single table is done with auto statistics based on a percentage of change and a count of rows changed before an auto statistic will trigger. So if you have a super large table, 10 million, 100 million rows, and it's waiting for 5% of the change to happen or 20% of the change to happen on your table before a statistic update will happen, then you may be waiting a really long time for 5 million rows to change, 10 million rows to change, or whatever the count is needed for it to trigger that. If you put in 2371, that will actually tell the system to change to a sliding scale. It changes the algorithm in which it uses to determine if your statistics need to be updated, if the auto statistic needs to run. So if you have large tables, million rows or more is what I like to talk about. Turn on 2371. You'll get more up-to-date statistics more frequently, and it will trigger that, and therefore you will get better execution plans, and your estimated versus actual rows will be in line. Also, for you developers out there, if you've ever looked at an execution plan, you may notice that sometimes the operator says missing statistic. If you hover over it and go to properties, that is an indicator that you should be manually creating a statistic that will give the optimizer information to make better choices. So if you see missing statistics and you hover over it inside your execution plan, it will tell you what it's missing. Maybe there's a particular field that it wants more information on, and it gives you that message. You can also create multi-field statistics. You just right-click on statistics, create statistics, and choose the fields that you want to be part of that. It can actually make things go much faster. So statistics can be a development tool as well, and can make your optimizer go much faster and your queries be much faster. So definitely be taking a look at your statistics. See when's the last time they were updated. Examine your large tables. If you have large tables and you are not on 2016, turning on trace flag 2371, there is zero negative effect on this trace flag, and it's highly recommended that you put it in, so much that it's now defaulted. So indexes, we've got about 15 minutes left, I think, or 10 minutes left. Let me see if I can get through these next two slides. Indexes is important, right? We all know indexes make our environment go really fast. A lot of us are really keen on adding as many indexes as possible for each query that's out there, but actually having too many indexes can cause you issues as you create a wasted I/O and put pressure on your CPU. So it's important for you as a DBA not only to do your index maintenance, which is your rebuilds and reorgs that all of us have been grown up to do, and we do often, I hope, but you also need to go and at least maybe quarterly or monthly or some point in your maintenance windows, I need you to be looking at your indexes and determine if they're being used. There is actually DMVs out there that you can look to see if an index is being called. Is it being seeked? Is it being scanned? Is the number of inserts into your indexes much larger than the seek and scans that are actually happening? Are you having so many changes to your indexes where you're really not getting the benefit? And maybe it's not used. Maybe there's zero seeks to it. Maybe in the development process, we thought we needed an index, but it's truly not something that is used by our consumer. You can actually script these out and disable them, check again for usage, and then delete them if they're not used. The DMVs that house this information on the number of seeks and scans, there's a lot of queries out there that you can borrow to run against your system. These actually get reset upon SQL Server restart. So I want you to keep in mind, if you restarted your box at the beginning of the month and you were looking at this on day 3 of the month, you are not going to have proper information in order to see what the true usage is. So before you go and examine these numbers, definitely take a look at when the last time your server was restarted or your SQL Server service was restarted to make sure these are good numbers for you to use. But you should definitely know what indexes are being used and what are not, and disable and delete indexes that are not being used. Now, missing indexes, this is one that we run into problems with a lot. Everybody wants to look at an execution plan where it gives us the red alert or the green alert that says missing index, 75% improvement, and you want to right click and script out and execute that index to fix your issue. Now, this sometimes can create problems for us because we end up with a ton of duplicate indexes. We also end up with indexes that are in the wrong order. SQL Server, when it actually gives you a missing index recommendation, it does it in table order and not necessarily the order needed for our query and our select statements that will justify the joins and the wheres in the proper order. And we end up with scans versus seeks. So I want to challenge you to make sure every time you see a missing index that you actually script that out and look to see what the index is telling you before you add it. Make sure that you're avoiding duplicates by checking to see if you have an index that already exists that maybe only needs additional included columns. Therefore, you're creating a covering index and you're not creating a duplicate index. It's much easier to modify an index that already exists by adding additional included columns than it is to create a duplicate. When you create duplicate, we get wasted I/O on our writes, we get wasted I/O on our reads, and we make the optimizer make more choices on which one to use in the environment, and we end up with a ton of problems. So how do we fix these two is I challenge you to, once a quarter, script out all of your indexes, throw the results of all the indexes inside Excel, simply put them in a sorted order that lets you easily find duplicate indexes. I want you to go through, and if you can consolidate those into a covering index, and that's just a matter of taking your included columns and maybe you have a duplicate index that you can combine the two. Or maybe you look at the ordering, and if you have field A and B, and then you have another one that's field A, B, and C, do you really need the index that has A and B when A, B, and C covers it? There's lots of things you need to look at, and you need to go into your environment. I guarantee some of you already have duplicates in there, and you're really wasting I/O on that. So definitely take a look. Covering index, we're going to talk about that here real quick. In execution plans, there's a thing called a key lookup. These are the 1, 2, 3, 4 items, if you know nothing about execution plans, that you can do to immediately speed up your environments. The biggest one here is this key lookup. If you have key lookups in your environment, you have wasted I/O. You have what I call death by 1,000 cuts. That means you have, if we have a store procedure that has 10 key lookups, and that store procedure is run 1,000 times a day, you have so much wasted I/O that you can really gain it back by making a very, very simple fix. If you look here at this example, we have an index seek. I have a query that says, select A, B, and C where C equals 1, okay? Look at that index seek. Maybe that index is on C. So my where clause gets a direct seek to C, which is what my where clause was, right? That's fantastic. I want to seek. But guess what? It also needs to return columns A and B. So it has to go out, do a key lookup to my primary key, get a match, and then bring back columns A and B. And then it does a nested loop to combine everything and brings it back to my select statement. So if I had this index that I had that had column C in it, if I did on that index a change and said include A and B, then guess what? I don't have to go back to my primary key to get A and B. My index now has C as my seek column, A and B as my tag along columns, my included columns, and it can completely return my select statement with 2 operators. I'll get an index seek and I'll get a select only. I will skip the nested loop and I will skip the key lookup, which is major when it comes to performance. If you have this going on thousands and thousands of times, you are actually creating and generating a ton of CPU and I/O and possible other issues with this. So definitely take a look in your environment, get rid of all key lookups that you have as much as possible, and you will see a huge, massive performance hit in your environment. Now, if you have tables that do not have a clustered index, you will see this as a RID lookup, an RID lookup. It is the same thing as a key lookup. I do have a blog on this. You guys can take a look and see the performance numbers when it comes to making these changes. Again, at SQLExpresso.com, you can go more into this. But again, execution plans, if you know nothing about them, I want you to get rid of your index needs, right? I want you to look for missing indexes. I want you to look for indexes that are being scanned versus seeked. It is very possible that your index was given to you in the wrong order and you created that missing index in the wrong order. Look and see what your SQL statements are actually asking for. And maybe you need to reorder your index appropriately in those lookup fields. So take a look at that. Sorts. Sorts are the number one heavy hitter when it comes to performance inside an execution plan. Why are you sorting? Can you sort on the application level? Can you sort inside the reporting layer? Lots of times when it comes to reports and select statements, it's actually resorted in the report. So why are you sorting it inside your code? Many developers, including myself, when I'm writing a store procedure, every time I write a select statement or whatever statement I'm running, I may add an order by at the end so I can double check my data. Well, when I'm going through and I'm done with that procedure, I need to make sure I'm going back and taking out any order bys that aren't necessary for my result set. Every single order by is extremely expensive. You can take and create massive performance gains just by reducing the amount of sorts that you have going on in your code. So definitely take a look and have the discussion with your report writers or the application layer side and see if they can do the sort and you can get rid of the sorts in your code, okay? The last thing is spills to TempDB. I've got 1 minute. Hopefully we can wrap this up. But spills to TempDB is all about your statistics. It's about having your estimated plans and your estimated rows versus your actual offset. If your estimated rows are way below your actual rows, then it has to spill to TempDB. It's going to use your TempDB and go to disk to do the workload. We really want our memory grants to be correct so we can do all of our work in memory and things go faster. If your estimated versus actual rows are off, then it needs more space to do the work. It's going to go to spill to TempDB, and you're going to force to disk. So if you highlight over this exclamation point and it says spill to TempDB, I need you to check your statistics is the number one thing that you do. And look and see if your estimated versus actual are out of sync. If it is, it's possible that all you need to do is a statistics update. And therefore, your problem will be solved because you will get the proper memory grant to work on that. Now, later versions in 2017, 2019, I believe it was 2017, there is a thing called memory grant feedback, and SQL Server starts to fix this proactively for us on subsequent runs of the statements that come through that spill to disk. So things are getting better in like later versions, which you can actually get those gains by just upgrading and doing patching on your environment to take advantage of these latest, greatest tools that they've put in there. So I am out of time. I know I went fast. I do talk fast, and I apologize for that. But again, this is usually a 90-minute session. I do have the slide deck on my website, which is here, as well as all the blogs I reference and any scripts that you may need on my site. But please don't hesitate to ask me questions. I will be more than willing to do that. I'm looking in the chat here. When you suggest using page and row compressions, I do say you want to use page and row compressions. It's very important for you to do so. It also has to do with the type of data type you are using on particular fields that you are compressing and in your indexes, etc. I do believe I have a blog on that as well. Definitely become knowledgeable on the difference between page and row compression. Row compression usually has to do with having varchar data types. The extra space that is not being used gets compressed on the row. So if you are using non-determinate type data types, that can be a real saver. Other times to use page is when you're not going on that row level. Page compression is kind of my go-to because I want to get as much on the page as possible. But definitely do some research on that. It is important that you use that and can keep more data into memory. I will give you a direct link to the presentation in just a moment. Let me see if I can grab it here so you guys have it. Are there any other questions? Here is the link to all of my session downloads. This one, as well as my TempDB session, is there. There's a couple recordings that I have on here as well if you want to rewatch it. Again, SQLespresso.com. Hit me up on Twitter at SQLespresso, and I will be happy to answer any of those questions. So thank you guys very much for joining me. I appreciate you taking the time to sit in my session when there's such other wonderful sessions going along. So you guys, there is a Q&A I see that will be in the auditorium. Hopefully you guys can enjoy talking to some speakers there. Again, if you have any questions, let me know. Thank you guys very much.